Alright, students, here we go. Always, sometimes, never. Dangerous, dangerous. Let's get started. Two lines are parallel to the same side, to the same line, are parallel to each other. This one's an always. Doesn't matter how many dimensions you throw in. If you've got two parallel lines and they are parallel, one of them is parallel to another line, all three will be parallel. Two lines that are perpendicular to the same line are perpendicular to each other. Now this is actually a sometimes. Sounds kind of crazy. I've got my handy little drawing over here. If you take this line that's vertical and scoot it down to where you've got an intersection, so example, you've got those lines that are in the plane, two lines are in the plane, and I call this one line A and line B. Line A can be perpendicular to line B. Line C is also perpendicular to line B. But A and C, because of that verticalness, could be perpendicular to each other as well. That's going to be a sometimes. Dangerous. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. This is an always. The product of perpendicular lines is -1. This one is rough because you've got the 0, example 0 over 4. That's going to be a horizontal line. And 7 over 0, this is your undefined, because this can't do that math. So I'm going to say sometimes. I wish they had a most of the time, but sometimes the product of the slopes of perpendicular lines is -1. The product of the slopes of parallel lines is 1. Sometimes. Example: if you've got both lines have a slope of 1, they are going to be parallel. I shouldn't have done that. More importantly, move along. All lines with slopes of 0 are vertical lines. Never. Never true. Slopes of 0, flat lines, they look like this. If corresponding angles are supplementary, then the lines are parallel. Now I'm going to write this down. Some of you are panicking right now. Sometimes, but corresponding angles are congruent. That's true. But you can have congruent lines, or you can have congruent angles that are also supplementary, like that. There's a set of corresponding angles that are supplementary. If line M is perpendicular to line N, and line N is perpendicular to line P, then line M is perpendicular to line P. That is a lot of crazy. This is going to be a sometimes, and I'm glad I already have this drawn out. Here we go. I'm just going to change the names. So line M, here we go. Line M is perpendicular to line N, and line N is perpendicular to line P. Then line M is also perpendicular to line P. That's a sometimes. Other times, you'll have line M is perpendicular to line N, and line N is also perpendicular to line P. P and M are not perpendicular. In this case, they're parallel. So sometimes yes, sometimes no. That gives you a sometimes for that answer. Two lines perpendicular to the same line are parallel. Not always. You've got two cases here. They're pretty much the same case. Not always. This one is also a sometimes. Gracious. 3 dimensions are hard. 3 dimensions are hard. Continuing on. Identify each pair of angles. Angle 4 and angle 6 are alternate interiors. Remember, they don't have to be congruent. That's just the name. That's why in your proofs you can't have alternate interior angles are congruent. They are not always congruent. Oh, my bad. This is same side. Don't let me talk crazy. Same side interiors for 4 and 6. We've got 9 and 4. 9 and 4 are going to be corresponding angles. 3 and 2, they are also going to be corresponding angles. 11 and 2 are going to be alternate exteriors. And then 7 and 5 are going to be alternate interiors. Find the slope of the line containing these 2 points. I'll have 0 minus -5 over 0 minus -3. It's going to be 5 over 3. Done. Find the slope of the line parallel with the equation. So really all I need is the slope of this line. Parallel lines have the same slope. Pull that 6x from both sides. -8y is equal to -6x plus 10. Divide the -8 off. All I really need is this, positive 3 over 4. That'll be the slope of the line, parallel to that one. Next page, find the slope of the line perpendicular to this equation. Again, all we have to do is find the slope. That's super handy. So I'm going to move that 4 to the other side, and I'll get negative 8y is equal to negative 4x plus 10. I'll divide both sides by negative 8. That's really all I need. 1 over 2 is this slope, so a perpendicular slope would be the exact opposite, the reciprocal. Negative 2 over 1. That's going to be that slope. Write an equation in slope-intercept form of these points. Remember that you've got y is equal to mx plus b, so if they give you the y-intercept like they did here, you can go straight to that equation. I'll have 2 minus negative 3 over 5 minus 0. 5 over 5, that gives me a slope of 1. So y is equal to 1 times x plus a negative 3. I'm just going to write minus 3. That's going to be it. Standard form for a line containing this point and having this slope. I'll have y minus y1, which is negative 8, is equal to mx minus x1. And to show you that equation one more time, y minus y1 is equal to mx minus x1. Looks just like that. We'll distribute that negative 3. And then I want the x and the y on the same side, because we want standard form. X and y on the same side, so 3x plus y plus 8 is equal to 12. We're going to subtract the y from both sides. 3y plus x equal 4. Standard form, x and y are on the same side. X is positive, no fractions. Slope-intercept form of a line parallel to this and passing through this point. Again, I'm going to go back to that y1, mx minus x1. I'll have y is equal, no, I'll have y minus y1, which is 7, because I want the line to go through this point, is equal to m, since it's parallel, same slope, x minus x1. And slope-intercept form, distribute the 4. Move the 7. And we got it. 17. Standard form of this equation, and it's going to be perpendicular to here, going through this point. Need this slope. Move the 3 to the other side. I'll have negative 4y is equal to negative 3x plus 12. Divide the 4 off. 3 over 4 is this slope. I want it to be perpendicular, so negative 4 over 3. Putting it into the y minus y1 equation, we'll get y minus 0 is equal to negative 4 over 3. X minus 5. I'm going to multiply both sides by positive 3 because I know in standard form I don't want any fractions. So that'll give me 3y is equal to negative 4, x minus 5. I'm going to distribute that negative 4 and get 3y is equal to negative 4x plus 20. And then I'm going to move the 4x to the other side. 4x plus 3y is equal to positive 20. All done. Tell whether the line's perpendicular, parallel, or neither. This one's going to be neither, not challenging. We've got a flat line and a line that is not flat or vertical. Easy. This one, also going to be neither. We can take and work this one out for you. Move the x to the other side, divide by negative 1. Y is equal to 3x minus 10. Move the x to the other side, no dividing. Y is equal to negative 3x plus 10. These are not reciprocal slopes, so we're done. This one. You have y is equal to this, y is equal to that. I'm going to switch this around to make it look pretty. We'll move the 5 to the other side. And on this one, I'm going to switch this one around, the x and the y. They both have a slope of 1. They will be parallel. We'll cut the video here.